Good morning, good afternoon, and good evening. Welcome back to Chapter 6. We are finishing up the electron transport chain. We have taken a molecule of sugar and we have stripped as much energy out of it as we can. We're at the last step. We're about to get the energy out of these molecules, these high energy molecules that we call NADH and FADH2. Let's talk about how we actually pull the energy out of these high energy electrons. Remember, these two little blue dots represent electrons that were pulled off of the sugar molecule. These are high energy electrons. We're going to get the energy out of them. Let's talk about how we get the energy out of them. So we said in the last video, we said that step 3 takes place across this inner membrane. This is a mitochondria. This right here, this is that inner membrane of the mitochondria. This is the outer membrane. Outer membrane, inner membrane. Remember, we talked about the intermembrane space. What does inter mean? It means between. The name literally means the space between the membranes. Okay. Step 1.5, step 2 happen within the mitochondrial matrix. This here, this area here, is the matrix of the mitochondria. It's the goop inside of that center membrane. So my step 1.5 is happening in here. My step 2 is happening in here. So all of those NADHs that we're making are being created here. We said that NADH is going to dump off its high energy electrons to a bunch of carrier molecules. And those carrier molecules are going to get the energy out of the electrons. Here are those electrons. They're going to get dumped off of this NADH and they're going to get added to these carrier molecules. And those electrons are going to be passed from one carrier molecule to the next. And at certain stages, the energy in those electrons will be used to take hydrogen ions that were made by ripping electrons off of the sugar molecules. The energy within these electrons is going to be used to shove these hydrogen ions into that intermembrane space. The energy carried by NADH is enough to shove 1, 2, 3 hydrogen ions into the intermembrane space. We said FADH2 doesn't carry as much energy as NADH does. It drops off its payload one step down. So it only has enough energy in it to make 1, 2 hydrogen ions go to that intermembrane space. And remember, we talked about diffusion. Diffusion says, if I have a lot of something here and not much of it there, what is it going to want to do? It's going to want to go from where there's a lot to where there's not much. The problem is it can't get through this phospholipid bilayer. The hydrogen ions can't get through that inner membrane. What the mitochondria does is it gives the hydrogen ions a back door. It gives it a way back in. And the way back in is called ATP synthase. It ends in ASE. What does ASE mean? ASE means enzyme. What do enzymes do? Well, enzymes make or break something. Well, synth means to make. So this enzyme, ACE, makes something. Guess what it makes? Its name is ATP synthase. The name literally means the enzyme that makes ATP. The way the enzyme makes ATP is by allowing these hydrogen ions that want to get out of this intermembrane space really bad. It gives them a way to go through, but only if they shove their way through a very difficult to push revolving door. Have you ever gone through a revolving door that was hard to push? Sometimes it's because that revolving door has a generator on top of it. Meaning, as you shove your way through that revolving door, you're spinning the door. And the door is spinning a generator. What do generators do? They make electricity. Some of those doors are making the people that go in and out of the building make electricity for them by spinning the door. As the hydrogen ions that desperately want out of this narrow space shove their way back through into this larger space called the matrix, they literally slam the battery back on the charger to make a charged battery, to make that molecule that we call ATP. The energy carried by NADH is enough to make 3 ATPs this way. And the energy carried by FADH2 is enough to make 2 ATPs this way. And when we talk about when you got done at the end of the night and you had $4 in your pocket and your manager gave you 34 more, remember those 34 were made using this process. I have 10 of these, that's 3 each, that's 30. I've got 2 of those, that's 2 each, 2 times 2 is 4, 34. The mitochondria is the powerhouse of the cell. The reason why the mitochondria is the powerhouse of the cell is because of those $34, how many of them were made here? Excuse me, of the 38 that you went home with. All 34 of them, of those 38 were made here. And actually, remember, step 2 is where I made 2 of those ATPs, and that happens in here, so that's another of the $2. So of the $38 that you made, 36 of them were made in the mitochondria. That's why it's the powerhouse of the cell. Because 36 of the 38 ATPs are made in the mitochondria. And if you don't have functioning mitochondria, then you can only make $2 per glucose instead of 38. That's why the mitochondria is such a big deal. Here we see the totals for the whole process. I start off with my glucose molecule. I'm going to split it in half. I get 2 ATPs and 2 of those NADHs. I then take my acetyl-CoA and run it through step 1.5. I get 2 more NADHs. I make acetyl-CoA. I take acetyl-CoA and I put it into the citric acid cycle. And each time I run the citric acid cycle, I'll get 1 ATP, 1 FADH2, and 3 NADHs, but I don't have 1 acetyl-CoA, I have 2. So all told, for 1 glucose, I'll get 2 ATP, 6 NADHs, and 2 FADH2s. Each one of these NADHs is worth 3 ATP, $3 tip. I've got 2, 4, 10 of them. 3 times 10 is 30. Each of the FADH2s, that's only a $2 tip. And I have 2 of them, so that's 4 more. So 34 ATP is how many make in the electron transport chain. The 34 from the electron transport chain plus the 4 from step 1 and step 2 means I get a total of 38 ATP for 1 molecule of sugar. 38 ATP.